welcome to week 8. We're going to go over problems 1 through 4 with the key, and then we're going to do problem 5 together. And that's
like the instructions said.
Yep. So, just as a disclaimer, we did not do problem 5 when we submitted it individually. Supposedly, we're supposed to do some sort of separate submission for problem number 5 after we do it together. So we'll send you an email about this, but we were thinking it might just be sufficient for us to like show our work to the camera at the end. So hopefully that's good enough, because I don't own a scanner.
We were kind of confused about exactly what the instructions were wanting.
Yeah, a little bit. Yeah. Anyway, so that's what we will do. We'll email you about it. So, yeah. Problem number 1. No. So, elk have a total of 68 chromosomes. How many total chromosomes would be the following types of elk? So, we had a little bit of a discrepancy on the first one. We were confused as to whether or not 68 total chromosomes was 68 diploid, or was the haploid number. According to the answer, it was the diploid number. You understand that?
Yeah, I get it.
Yeah, so like 2n equals 68, so 4n would be 36. So disomic would be regular, right?
Yeah.
68. Trisomic for 1 would give it 69, right?
Yes.
Monosomic for 1 would give it 67.
Yes.
And then a reciprocal translocation would not affect the number of chromosomes, correct?
Yeah.
Sweet. All right, we did stellar on number 1. Okay, number 2. So, what is associated with the Tau syndrome? What did she say?
Aneuploidy, trisomy, and non-disjunction.
Sweet, got that right. What about conventional Down syndrome?
Aneuploidy, trisomy, and non-disjunction.
Sweet, got that right as well. What about Turner syndrome?
Monosomy, aneuploidy, and non-disjunction.
Yeah, that's what I wrote. I also wrote deletion because apparently this is really specific. I was reading about this online, but apparently deletion can cause partial monosomy, which can also be considered Turner syndrome, but not for our purposes, I don't think. Is it relevant? So, what about D?
Deletion.
Yes. And what about E?
Reciprocal translocation.
Sweet. Nailed it. Did you have anything confusing about that?
No.
Alright, so 3. I think we screwed all up, but we didn't know how to fix it. I didn't know how to fix it, so. It's all janky, and I need the answer key to know how to do this.
Product 1. The paternal.
So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O?
Yes.
What? Okay.
Product 2. A through E paternal, F, G, H, V, A maternal.
Wait, what? Okay, let me see this. Let me see this on there. What the heck? Okay, let's write this down. So use the smart groups. Heck knowledge. Okay. So I got the first one, right? Kind of. No. Yes. Yes.
We got
Yes.
one of the products right, but it wasn't listed as the first one.
Yeah, I don't know if there's a normal like order for the products. I don't think there has to be. So we're gonna end up with A, B, C, D, E, F, G, H, I, J. Centrosome. Centromere, sorry. K, L, M, N, O. That makes sense. Also, this one makes sense. A, B, No, wait. Yes, because that's the maternal.
Yes.
So we have a maternal and a paternal type. A, B,
I was correct about those two being,
D, I, J.
but I don't.
Yeah, I got those ones. I didn't know about the other ones. KLMNO. So our other products are weird. So it looks like those are caused by a crossover that's. Oh, okay, I think I get it. So there's a crossover between the E and the F alleles. So that means that there's a crossover happening after the E alleles, not just for the E and the F. It's
Okay.
after that. So that means that you're going to have regular, right? You're going to have A, B, C, D up until E, and then suddenly you're going to get everything that's maternal. So you're going to get E, D, C, I, J, K, L, M, N, O, right? Isn't that what this one is? Oh, no, wait, that one's. Yeah, no, so you're going to get everything that's after the this direction. One there. Oh. I wonder if it goes that way. Oh, because it's flip flopped. So instead of cutting it off here and going this way, it's going to go E, and there's going to be a crossover, and it's going to read this direction because it's between the E and the F.
Okay.
So you're going to have A, B, C, D, E, F, G, H, B, A with no centromere. And then your other one, let me make sure I've got this so I can get it right. Your other one would go from here to there. So go O N M L K centromere J I H G F, and then it would cross over E D C I J centromere K L M N. Is that what they wrote? Okay, do you understand?
I get this one. Oh, but this.
Okay, so basically what happens is you have a crossover between E and F, right?
Yeah.
So this half is going to go one place and this half is going to go somewhere else, right?
Yeah.
So this splits in half here and this splits in half here.
Yeah.
So what you're going to do is you're going to link this E to this F and this F to this E. So it's going to want to read EF, basically.
Okay.
So you're going to read, and then it's going to go, whoa, EF split, and it's going to attach the E to the F here. So this one is going to have these two ends. Whoa.
Okay.
And then this one's going to have these two ends. Honestly, I think this one actually might make more sense if they wrote this direction. O N L K J I C D E F G H I J K L.
Okay.
So these are going to be your four
And that's
products.
making a little more sense.
Yeah, and then this one's going to touch this one. A, B, C, D, E, F, G, H, B, O.
Okay.
Okay, so let's try and answer, without looking at the key, let's try and answer those other parts of this question again to make sure we understand. Alright, which of the four chromosomes are expected to produce viable offspring? So I would say that the
One and four?
paternal ones would produce viable offspring. My guess. Because these two, they both have a full set still.
Paternal and maternal.
These ones, I would think,
1 and 4.
yeah, 1 and 4. Because they're the paternal and maternal.
Yeah.
Well, you had to let me finish explaining. Now you told me the
Oh.
answer. Now I know I'm right. Don't jump the gun on the answer key, man.
Sorry.
Okay, but then this one wouldn't be viable because you have essentially a huge deletion. And then this one wouldn't be viable because you have 2 centromeres and it's all crazy. Yeah. And you're also missing a large proportion. You're missing A and B. All right, which of the 4 chromosomes contains deletions or duplications? That's 2 of them, right?
Yes.
That's product. According to their thing, it's products 2 and 3, right?
Yes.
That's what he says. Yes, sweet. All right, which of the 4 chromosomes are acentric or dicentric? So we have our product 1 and product 4 are regular, if you will.
Acentric.
No, mono.
What?
Mono means 1. Acentric is without.
Oh.
So it's
Acentric would be
product
2.
2 is acentric.
And dicentric is 3.
Yeah. Yep. Sweet. Yeah, the rest of the problem was fairly easy. It's just knowing how to do that across. All right, 4. An individual who has suffered a reciprocal translocation possesses the following chromosomes. None of the letters. Okay, so this is about translocation crosses that are alternate, adjacent 1 or adjacent 2. So let's check the answer key. Is this for 4?
Yes. So A, the regular, and the translocation.
Oh, oops, yeah, okay, WX. I was just reading the wrong thing. I was like, what? I wrote the wrong one, but I totally understood this.
And then
And
A, B
then,
regular, and R is translo. A, B translo, and R is regular.
And then in the last ones,
A, B regular, A, B translo. R is translo.
sweet, we did that right. Okay, time to do number 5 together. This question you'll examine non-destruction. The first paragraph of this question asks you to draw the results of non-destruction in meiosis 1. The second part of this question asks you to draw the results of non-destruction in meiosis 2. In your drawings, diagram the behavior of 2 pairs of homologous chromosomes. 2 pairs of homologous chromosomes. Use color to distinguish the maternal and paternal chromosomes.
So the
Also diagram the nuclear membrane, the microtubule spindle, and the metaphase plate.
So basically so for this is the one where they're in meiosis 1 will cause more chromosomes than 2 and less chromosomes than 1, correct?
Huh? What?
The non-disjunction.
Non-destruction or rather.
So this one is where it goes like this instead of like this.
Yeah, so non-disjunction happens when they line up for crossing over, I believe. And then instead of coming apart like they're supposed to, they just kind of stick together. And you end up with, in meiosis 1, you end up with a cell that has 3 chromosomes and 1 chromosome instead of 2 and 2. And then if you have non-destruction in meiosis 2, you would end up with a line up, and then you end up with 3 chromosomes in one and 1 chromosome in the other. And yeah. Let's work through it. So let's get a handy dandy piece of paper here. Okay, so in meiosis 1, we start at prophase 1 with a zygote. So I'm going to draw everything with the same colors because I can. So here's your cell. Inside your cell, you got a pretty old nucleus. And inside the nucleus.
We just need to draw the metaphase.
What? But I want to do the whole. Okay, whatever. Doesn't matter. Doesn't. crossing over happen at prophase 1?
We're not crossing over. We don't need it to cross over. Because, so what's going to wind up happening is metaphase 1
This class is making me a lot better at drawing stars. From some that is. Okay, well,
So there should be two.
alright, well, I already drew prophase, so sorry about that. It just happened.
So it's
So after prophase, you have
So-
metaphase. Right?
it's gonna mess up kind of like this. And
So normally what you have happen in metaphase is that they line up and they split along the metaphase plate, right?
and then anaphase,
And then in anaphase they pull apart.
yeah.
So let's draw metaphase. My cells are shaped like avocados.
I started writing anaphase in blue and then finished it in black.
You know what? Okay, prometaphase, you have the cell membrane has dissolved, right? Metaphase, sorry. So I'm gonna draw that. Dissolved. You got a nice metaphase plate down the center of the cell. Did you draw your metaphase plate? Metaphase plate. That's where they line up.
Oh,
You also got some centrosomes that pull it apart. Make my centrosomes yellow. So on one side, you're going to have I'm going to assume some crossing over happened, although I'm not drawing it. Because what's good stuff without crossing over, right? So they're all lined up here, ready to go. The little spindles have come out and attached. So metaphase 1, they're all ready to separate. Right? And then the trouble is at anaphase, right? Because they pull apart and you're going to have...
so they'd wind up pulling apart.
Sorry, I'm a slow drawer. But my things are very colorful. So that should be something, right? So instead of having it nice and normal like it's supposed to be with 2 chromosomes on each side, ah, 3 on this side, and then 1 on the other side, right? They got stuck. Oh, destruction. What does that look? Good.
Yeah. We're going to have to keep those connected.
The only issue I see with yours is the color coding for parental. Because when they line up along the metaphase plate, you should have one from each parent. You should have one paternal and one
Yeah.
maternal.
So, I don't have enough colors.
It's not like I'm saying you can't use mine.
Okay.
You have a lot of colors.
Restart.
Well, I mean, yeah. Whatever, do your thing. I just wanted to win the race. That's why I criticized your drawing.
Fun.
I mean, it worked. And then we have telophase, where the cell splits. Whoa, 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 whoa. And then cytokinesis, where you actually have two. Cells. You have a reforming of the membrane. And then one of them you end up with three chromosomes. And the one you end up with only one. Crazy.
Correct. Yes.
Why are you making them four different colors? You need to color them for the fraternity. Because they're homologous pairs. It's easier if you just make them different sizes for different chromosomes. Does that make sense? The only reason I did more than one is because I want to show that there's not only, because you need to have trisomy.
Okay.
Does that make sense? So you want to make just by sizes you can show.
I will. On.
Okay. Alright, so this is parts prophase 1 through through telophase 1 and cytokinesis for a non-disjunction in meiosis 1. So I'm 1/4 of the way done with this. Another piece of paper here. Here's what I have so far. And that is not very clear. I don't even have to scan this in. So that's the meiosis 1 of a non-disjunction meiosis 1. So now I'm going to make meiosis 2 for non-disjunction meiosis 1. Maybe stellar. phase 2. So the difference in this metaphase is that you're going to start out with your daughter cells having, instead of having one set of each chromosome, you're going to have only one chromosome and the other. Since we're starting at metaphase 2, our membrane.
That looks like a lot of fun, YouTube.
Thanks. We're doing our recording.
It's like
Meiosis 1 and 2.
mitosis. Is that what it is?
Meiosis.
Meiosis. Hey, at least I got one of the words. Kind of close. Did I go over to visit Julio?
Yeah.
Well, I'm going to listen to music while I study something.
Okay. So once again, we have our metaphase plates. Our centromeres going forward.
Yes, the non-distension happened in both metaphase 1 and 2.
No. So you're gonna do a full thing of meiosis for non-destruction in 1, and then a full one for meiosis in 2. For non-destruction in 2.
Huh? So for A, you just do it with only the non-distension and meiosis 1.
Exactly.
And for B,
It's
only
only
meiosis.
meiosis 2.
Yeah.
So for B, meiosis 1 will be. So we're gonna have it line up, and so in one cell,
And this one will possibly.
we're gonna have a blue chromosome. How would you choose the chromosome? You're like a timeshare on the orange pen. Spindles attached. Spindles, yay! cells too. They split apart.
So here's the phase one.
And then phase two.
And here's my I'm good
Are you all done
with the first one.
with part A?
Nah, first one, part eight. Right. Hello.
No, we should definitely compare. 1 second, I'm almost done with part A. Sorry, mine are just more complicated color-wise, I think. I don't know why I decided to make it complicated, but I did.
Wait, you're not done with part one?
No, I'm done with part. I'm almost done with part A.
I mean part A.
Yeah, I'm almost done.
Oh,
Sure, man.
I thought you were working on part two. Part B. Oh. I love how my cells they're nice and big and then nice.
You do that. You do you. All right. So we have 4 daughter cells. And gametes, sorry. They are 1N.
Where's the order?
These ones are monosomic. These ones are trisomic. Wait. Here. Okay. Yep, looks good. Okay. I might do this smaller, like yours. You inspired me. On this junction.
Did I
And
do that backwards? No.
meiosis.
Change
Two.
it now.
Silly to draw meiosis 1 when no instructions have one 2, but whatever. It's good practice. You never know too much about meiosis as a kid. Skip the inch. Okay, so metaphase 1. You have to include your centromeres and your microtubule spindles down the nuclear membrane. Just a heads up.
Just draw an extra circle around that.
And don't forget that it's dissolving in prometaphase. So I don't know if you want to do that or not. And it's also reforming into a phase.
Prometaphase?
Yeah, like that's the beginning of metaphase. Okay. Yeah, it's part of metaphase.
Yeah.
I've been including it.
I don't. I wouldn't know. Do we need to do the nuclear a little bit for these as well?
That's I have them. I included them. So they're forming here in telophase and then in the cytokinesis they're forming.
Nuclear. Right, totally different. What?
Yeah, one thing that was really nice about how really Calcium 481 is because I was kind of confused about these like distinctions. I was like these are very subjective, and he's like, yeah, so a lot of these are kind of like a process. And so we put labels on them like well because each of this process, so like two of these is when it's forming, so we like took these kind of snapshots, but there will be a lot of long boring videos to watch people drawing in. It's good for boys. I never wanted to. It's inspired, but I just maybe try to make it. was not very well done cleavage. So I played it right now.
We only need the non-disjunction for one of the two cells, correct?
I assume so. The odds of having them both.
True.
Like, I mean, I'm sure it has happened, but probability-wise, it'd be really unlikely, right?
Yeah.
Not really. Phase two.
Good idea. Good idea.
Which one should I have be the non-destruction? So Well, Lori. Chromosome 22 right there. Okay. Base, 2 and then 2. And alright, hang on. Alright. So in my non-destruction, meiosis 2. Anaphase that lines up on the plate, splits normally in anaphase, cleavage, and cases. Great. And so you end up with normal. You decided to keep the ones together?
I didn't pay attention. I originally did that.
I guess it doesn't really matter, like. But whatever. Anyway, so metaphase 2. You start out with daughter cells that have one of each kind of chromosome, nothing in the middle. And then when you split, pulls over both sister chromatids to one side. Right. So this will end up with 4 daughter cells, which are regular, one of which will make a monosomic all 3, one of which will make a trisomic all 3. Right?
Yes.
Sweet. Okay. I think we're done.
I guess we can submit these.
Well, I did say I was going to hold them up. So I'm going to hold mine up for the camera. Even though it does look kind of like they're not very good. So here's non-destruction in meiosis 1. Here's meiosis 1. And there's meiosis 2 with the non-destruction in meiosis 1. Not good quality. And here is The non-destruction meiosis 2. Meiosis 1 is on the top, meiosis 2 is
Come on. Here's the camera. There.
Hi.